Hello, my name is Mr. Chipman. I teach AP Biology at Murray High School, Murray, Kentucky. This is Unit 3 Populations 3.8 Human Population Dynamics, AP Environmental Science. Here we go. There are a lot of factors that can lead to the growth and decline of a human population. We're not talking about deer and porcupines and oak trees. We're talking about people, right? Which we've been talking about people the last few videos. So what are some things that can affect the growth and decline of a population? Directly is birth and death rates, right? The amount of people that are being born versus the amount of people that are dying is going to have a direct effect on the growth rate of a population, right? Infant mortality rate we discussed in 3.7. That infant mortality, if it's high, you're going to have higher fertility rates. If it's low, you're going to have lower fertility rates. Access to things like family planning, reducing fertility rates, unintended births, nutrition, and healthcare, increasing infant mortality, thus decreasing infant mortality, thus decreasing also fertility rates. Education, marriage age, anything like that. More education, less births. Higher marriage age, less births, right? And so what has happened to world populations? Well, the world is becoming more developed, and thus growth rates are decreasing. Very simple. This brings us to something called Malthusian theory. This has to do with Thomas Malthus. He was an economist in Great Britain in the 19th century. May be wrong on that, I'm not sure. I don't think so. Early 19th, late 18th century. And he was dealing with this idea of population overload. London was a very crowded place in those days, one of the largest, if not the largest city in the world, and was dealing with overcrowding, overpopulation, lack of food, all this sort of stuff. And Malthus came up with this idea that a population can only sustain until there is some sort of point of crisis, right? A point of crisis, a limited resource, be it food, space, mates, something, right? And at that point of crisis, the population is either going to adjust or crash. And so what we've seen with human populations is human populations have tended to outpace their carrying capacity, right? For centuries upon centuries, human populations were sort of hunter-gatherers, and they kind of followed the herds around, and the populations didn't grow very much, grew, but not very much comparative to other populations on Earth, other animals. But then we started to advance, started to have some technological advancement. Those technological advancements allowed us to sort of bust through our carrying capacity. As we've developed agriculture, as we've developed all sorts of other different technologies, we've been able to slowly break through those points of crisis and increase as a population. Eventually, obviously, that's going to run out. There is a place where the human population can no longer increase and is going to have to deal with the fact that there's a limited amount of resources for the current population. So this is the idea behind Malthusian theory. It's a really important concept in understanding economic growth and understanding population growth. Very important. Typically, human innovation is going to help break through those carrying capacity moments, but eventually there is a limit. Speaking of limits, limiting factors. There are two different kinds of limiting factors. There's density-dependent factors. These are things that are like biotic or living. Natural disasters. We don't have tigers eating people. I mean, at a high rate, or owls. Owls are significantly lower than tigers. But any sort of living thing, density independent, or density dependent, or living, sorry. And this would be disease, this would be food availability, clean water, space, anything like that. Density independent factors are going to be things like natural disasters. These affect populations regardless of their size, right? A volcano or a forest fire or drought or any other natural disaster that you can think of is going to affect a population regardless of its size, whereas disease, any sort of density-dependent factor is going to affect that population more if that population is larger and if they're more dense. Here's an example to look at. This is Ireland from 1821 to 2011. It's a pretty big margin, 190 years. What happened in Ireland in the 1840s? Well, there was something called the Irish potato famine, right? The Irish potato famine claimed at least 1 million lives of starvation, probably another million more or so to emigration, which is exiting the country. And so over the next centuries, or dozens of years, the population struggled to recover from that. It's a significant event. And you can see that since the low point in approximately the early 1920s, 30s, that the population has started to increase since then, right? And so this is a great example of how populations struggle as a population that is like a K-selected species, like humans, is going to be slower to recover than an R-selected species. And that recovery can take a century even. And I think this is a great picture of that. This is the Rule of 70 again, just a little practice for us. A country has a population growth of 2.5 per year using the Rule of 70. What is the approximate doubling time? We're going to divide 70 by 2.5, and we're going to get 28. A is the correct answer. Hope this was helpful. Looking at 3.9.